Morning, guys. If you can hear me, type something. Say yes, so I can continue with today's material, today's topic. If you guys can hear me, just type yes. I want to make sure you guys can hear me before I. Okay, great. So obviously somebody can hear me. Good. So today I want us to cover the IP address. It's a huge part when it comes to the communication, especially part one. Um, it's where you basically learn what IP addresses are, their formats, their uses, what role they play, and in data communication in general, especially for devices that are connected to a network. Uh, what various uh, interplays in terms of routing they convey to various networks that you have, how to secure them, how to make it much more uh, efficient and effective, especially given the fact that their allocations are quite minimum, especially for the version 4, which can only support about 4 billion IP addresses. And considering the fact that the world's population is over 7 billion now, and we have quite a number of gadgets. We have billions, we have trillions of gadgets today that are trying to connect to the internet, and they all need a way of getting onto that any given network. And the only way they can do that is if they have a way of addressing it. You know, a device can never be part of a network if you cannot uniquely identify it based on a specific address. So IP address serves that purpose. It basically creates this unique address for a given device that wants to participate in any kind of data communication or any kind of information exchange on the internet. So ideally, it's always a requirement that students go through some of these basic address and uh, concepts that devices are more or less exposed to in terms of communication. So I want to go through that. Before IP addresses, there are MAC addresses. MAC addresses are usually what you call the media access control addresses. They're the physical addresses that are assigned to most hardwares that participates or that basically has um, the requirement to be able to allow for information to be exchanged or to be able to allow for that particular device to be part of a given network. Every device that's designed to participate in any kind of network transmission requires a physical address. So for instance, your cell phones, before they even get IP addresses, they have a physical address. Your laptops, your servers, your computers, your access points, all those other gadgets that you use to interconnect other devices or link up to other devices on a given network by in its fundamental basics must have a physical address called the MAC address. The MAC address is the only unique address in the world that's given to every single device made to exchange information on a network. So let's assume that today or tomorrow, you decide you're going to be a computer or a cell phone manufacturer. One of the first things you're going to be needing if you want that cell phone to be able to actually play the role as a communication device is to make sure you get a MAC address for that cell phone. So every single unit, every single device that is built to participate in any kind of information exchange on any network must first of all have a physical address called a MAC address, or MAC, a MAC address. Like I said, the MAC address, or the media access control address, is the only unique hardware address that every single device is assigned to on a given node. Now, because of the fact that it's unique, it's actually managed at a high level by the International Telecommunication Unit, as well as the International Standard Unit. But it's actually grouped under the IEEE organization, which is the Institute of Electronic and Electrical Engineering. They are the main body that are designed to basically manage physical addressing of any network device that we have. So if you're going to build a cell phone, you probably have to talk to IEEE to give you a unique physical address for the number of devices or the number of cell phones or computer devices you're going to be building. Without them, I guarantee you, your cell phone will never, ever, ever function as a cell phone. That's just a rule. So IEEE is the main organization in charge of that. And MAC addresses operate at the data link layer, which is a layer 2. Okay? Those are the ones responsible for exchanging frames. Okay? So anyways, on any network, you need devices with MAC addresses. And MAC addresses are the most unique addresses of any device that you'd have on any network. IP address, on the other hand, are actually logical addresses because they're only assigned when a device gets onto a network. Hence, it's a logical address. It depends, it has a condition to it. A device can only get an IP address if it gets onto a network or if it's allowed onto a given network. But MAC address, on the other hand, whether the device is on a network or not, it must have that address. Okay? So keep that in mind. So your network interfaces, so a typical address, physical address for your cell phone will probably be assigned to the wireless antenna that's built on the board of your cell phones. For your laptops, it would have both the Ethernet port as well as the wireless antenna. That's why when you were to, if you were to go onto your computer and you type, you go to command prompt and you type, let me see if I can, you type get MAC. That means get the MAC address of the computer. You're gonna have multiple physical addresses show up. Now, the first two here, my machine has, usually most laptop would have only two. Now I have three because I have a virtual machine on my laptop running. So hence I have three. So the third one also has its own virtual physical address. But without the virtual physical address, I would only have two. So for the most part, you guys, if you're to go into your computers, as long as you're not running any virtual applications or any kind of VPN connections on your systems, you should have two physical addresses. And this physical addresses, or the MAC addresses, are usually in hexadecimal format, which means they are in both, you see them in alphabets and numerical and numbers. And they are about, so hex 1, 2, 3, 4, 5, 6. 6 times, what is 6 times 4? No, what is 6 times 8, guys? Oh, hey, you can unmute your mics, guys. I think let me just give you guys that option to unmute. Okay, you have the option to unmute yourselves. Are you guys on mute? Hello?
Say 48.
48. Great.
48.
So MAC addresses are made out of 48 bits, unlike IP addresses, which are made of 32. MAC address consists of 48 bits, whereas IP addresses have got 32 bits, which is 8 times 4. So it's 8 times 4 and 8 times 6. So it's 8, 8, 8, 8, 8, 8. 8 times 6 is 48, right? And then 8 times 4 is 32. So MAC addresses are made up of 48 bits, and they are grouped into 6 hexadecimal dotted formats or hyphenated formats. So you'd have it in this format. So in this case, I have D425, 8B, 5B, 5E, and 2D, making up one of my Ethernet, a physical address. So this could be for the wireless, and this could be for this is actually for the wireless. Okay, so the first one here is for the wireless. My guess is the second one here is for the Ethernet. So another way to find out is just type ipconfig, and then wireless has got the, okay, this one has got the, let me see if I can find the, oh, let me type get all. I can get all these deals. Okay, so the wireless adapter has got the physical address that we saw earlier on. So this is the physical address D4. So if you go all the way up, the D4, the last one is 2D. 2D, where are you? Wireless, 2D, here we go. 2D. So this is for the wireless adapter. I have both, the virtual one gives me the 2E. I have both virtual adapters. The virtual adapter also gives you its own physical address. But the one that actually comes with the machine itself, the direct one, is the one I have the 2D. So that's the 2D. And then the Ethernet one, so Ethernet, let's see the Ethernet one, Ethernet adapter. So this one is D9, the physical Ethernet adapter. So that's a D9, that's right here. So these are the two main adapters that came with the laptop. And the last one happens to be the virtual one. So like I said, if you don't have any virtual system or VPN configured on your laptops, you will see only two. Okay. So anyways, that's, and then like I said, they're in hexadecimal format of what? 48 bits, or grouped into 6 hexadecimal formats. Okay. To get them, obviously, you have a way of getting it. You can just type, if you want to get your MAC addresses, you can just type get MAC. The command to get the MAC address on most devices using Windows is get MAC. Get MAC, or you can use the ipconfig /all. That should also give you that information. And as I mentioned, it operates at the layer 2 level. media access operates at the layer 2 levels. For different operating systems, you would have a different way um, of representing the physical addresses on your machines. If you were to be using Windows, you notice that the 6 groupings will be separated by dash. But if you are using a Linux machine or your Android machine, you will notice that, or your Apple machine, you notice that it's actually in commas. You would have a comma. So it'll be like in this format, your first hex, and then followed by a comma. So a column, what am I saying? A column. You have a column instead. It'll be a column separating the the 6 hexadecimal format that you have. But for Windows, it's hyphenated, uses hyphen. So keep those two in mind. If you do see them, just keep in mind that you probably use, if you see columns, it means that you're probably using a Linux-based operating system, like what you would have with most of your Android phones and your iOS phones. They are mostly Linux-based or Linux-based. So they're going to have in the form of columns. But if it's a Windows machine, then it will be in hyphenated format. So that's the way it's been designed. And like I said, it's managed solely by IEEE. IEEE is the main under the ITU, the Institute of Telecommunication Union. So if you need a physical address for any device you're going to build that you know would be used for any kind of communication, then ideally you should talk to IEEE to give you that particular physical address. Now, the reason why physical addresses are managed solely by IEEE is because they are supposed to be the most unique address that every gadget that connects to a network must have. So we don't want a situation where you have 2 devices having the same MAC addresses. That will create a huge problem. So they've instructed IEEE to be the sole manager or the sole organization in charge of managing the address allocation. You can buy a huge block of it. So for instance, you want to make about 1,000 cell phones. Then you tell IEEE, I need 1,000 block of physical address or MAC addresses for 1,000 cell phones I want to build. Or you want to build 10,000 laptops, same concept. You tell them you're trying to build 1,000 or 10,000 laptops. So you need that many physical addresses for your devices. Now, it doesn't mean that they're gonna give you a machine that has got the address. Usually, when you build a network card, then they basically assign the address to that network card or network interface. So like the Ethernet cards on your laptops, which is built by either Broadcom or Railtel, they are the main guys that actually talk to IEEE because they're the manufacturers of most of our Ethernet adapters. So they are the one that talk to IEEE about the physical addresses, and then you, the manufacturer, will go to either Railtel or Broadcom and tell them, or 3Com, and tell them, hey guys, I need this block of Ethernet cards with MAC addresses that I want to use for my so-and-so device. Okay, so and then they basically produce it for you and give it to you, so you can take it back to your office, your factory, and then install them on the boards of those devices that you want to use for whatever that you're building. Okay, so there's a chain of command in terms of how physical addresses are allocated. like I said, since it's the most unique address and they don't want duplications, it has to be well managed. Like, can you imagine MAC address being managed by a Ghanaian company? There's going to be a lot of issues because people might bribe the company, and then you're going to see a lot of duplications, and all kinds of issues are going to start happening on networks. So some of these things have been well thought of, and the reason why they assign a specific organization to manage that particular role. They don't want to give it to idiots. That will create confusions on networks. Okay. So, anyways, that is how Ethernet uh, is set up in terms of its implementation for most devices. Um, since it operates at the layer 2 levels, it means that it's only good for forwarding frames. So when it comes to frame forwarding, after you move it from packets level, the next stage from which is layer 3, packets layer 3, is to hand it to frames. Frames are just a huge block of data with specific allocations given to them. And then from there, they go to what you call the bits at layer 1 of the OSI model, which is the physical layer. Now, what happens when a device wants to actually forward packets? So like I said, the MAC addresses are only good for forwarding frames. And frames are usually deployed at the or converted at the layer 2 level. But before layer 2, there's layer 3, which is the packet layer or the network layer, right? The network layer doesn't handle frames, it handles packets. So it also needs its own address. And that's where IP addresses comes into play. IP addresses are also unique in their own way, but technically they're just logical addresses. You can only get an IP address when you're connected to a network. And they usually lease out to devices from a DHCP server. So whenever you connect to a network and you get an IP address, chances are you got that IP address leased to your device from a DHCP server or a dynamic host configuration device system server or system. They are the ones in charge of basically giving out leasing out IP addresses. IP addresses can either be leased out dynamically or statically. And statically doesn't require you to actually have a DHCP server running. You can easily assign them yourself manually, okay, or statically. But the challenge with that is that assuming that you have about 500, let's say 500 computers on a given network, trying to go around assigning static address to all those 500 devices become a bit of a hassle. So ideally, system engineers build what you call a DHCP server to handle the lease of logical IP address to devices automatically or dynamically, without them going around, without the IT guys going around manually or statically assigning the IP addresses. IP addresses are made up of 32-bit binary numbers. Okay? 32-bit binary numbers, but they are represented in decimal format of 4 octets, which means there are 8 bits in each octet. So hence 8 times 4 equals 32 bits. Okay, I hope you guys are following. IP addresses are made up of 32-bit binary numbers, which have been grouped into 4 octets. So it's 8 because octet is 8 times 4, giving you 32. They are actually represented in the octets in decimal values. So whenever you're representing IP addresses in its octet format, it has to be in decimal. It wouldn't be in binary. You get to the binary part when it comes to the manipulation of for subnetting purposes, which you get to later. So the basics of IP addresses are purely on decimal formats of 4 octets. So in my setup over here, I have an IP address on my machine. On my wireless LAN adapter or my Wi-Fi adapter, and I have an IP address version 4 of 192.168.1.170, which is being assigned to me via a DHCP server, which has an IP address of 192.168.1.1. So that's a DHCP server issuing out this address to my wireless adapter. So if you notice, I can only get an IP address when I'm allowed on a given network. Unlike the MAC address, even if I'm connected to a network or not, it's just part of the system, built into the system. It just comes naturally. Sorry, I said naturally. It just comes as a physical configuration or built for the system I'm using, or for the computer or the device that I'm using. It doesn't change. It doesn't require you to request it from some kind of server. The very moment they're building a machine, there's a manufacturer is requested to basically provide the physical address, and then once you get it, you mount it on the board and it becomes literally fixed or permanent to that particular computer device that you have. Now, IP address would change as and when a lease is required, or so we say as and when it's leased and unleased. So today I might get this IP address of 192.168.1.170 from this DHCP server today. Tomorrow I might get a different IP address. So it has a tendency of changing. Unlike the physical address, which will always remain the same, it will never change. But the IP address will change depending on your DHCP's server settings or its lease configuration. Okay, and that's one of the reasons why we say IP addresses are usually logical, because they always have a tendency of changing based on a certain configuration that is stated by either a DHCP server or a system administrator. Okay. So once we got those two concepts between the IP address and MAC addresses, we want to really look at how those decimal octets are actually represented in binary, and that's where we come to the binary to decimal conversion. I know you guys took your computational math last semester